Beginner's Guide to Capturing and Streaming. We've been getting a lot of questions as it relates to the hardware of the 4 levels of computers we're talking about building. Some of you guys, let's see a show of hands, who want to install a capture device in your computer. We've talked about the entry level, the secondary, the 3rd level, which is the high-end desktop, and the 4th level, which is the workstation. Which one of these capture cards is best? Okay, I think what we need to do is step back and we need to do a historical perspective with a beginner's guide to capturing and streaming. So I've got some links I'm going to put up and show you. I'm going to show you some of the devices that we have used in the past successfully, and this is all about the hardware. There's a lot of ways of doing a lot of different things. Our goal is clarity, but the first thing we need to address is capturing, streaming, the bandwidth required to do all that with. We need to look at the hardware because there's 3 things with the hardware. 1, the device, input and output. And I will say, even though it can be done with hardware or software, because our goal here is clarity, and please, if there's anything that we don't answer based on this, because this is an overview perspective, ask your question. We'll do our best to answer it. Tell us what you want to do. We'll try to help you solve it. Because when this video is finished, our goal with the next 4 videos will be to look at 4 different devices and how that relates to doing capturing and streaming. Because where the technology's come from in the last 8 years, I think it's phenomenal what we're able to do. And whether you use a desktop or a laptop, and if you go another level, you don't have to have a computer at all to do streaming with. We might even touch on some of that. It's more of a professional type product, but it's kind of like going to the a hardware store and you need to hook up a toilet. Well, if you've been in the plumbing department and you don't know what you need, and you think you know what you need based on what you're looking at, well, it kind of helps to have an overview so you know what the possibilities are. So I hope that analogy makes sense. Another is kind of like grip for holding cameras or holding lights. If you don't know what's available, you don't know how to do some of that, kind of like shooting overhead. And we're going to also have links to all this stuff we're going to talk about as we go through this, because what we need to do is identify the product, the pros and the cons, what was good about it, what was not so good about it, and what are the specifications to make something like that work. Because always, and I need to preface this, whatever software can do, hardware can do better. And we're looking at a hardware solution for a capture device, or a lot of companies refer to a capture device as a capture card. And my definition and their definition are somewhat different. For me, from my perspective and my perception, a capture card is something that goes into a computer. A capture device is something that works externally. But a capture device can also be something that doesn't require a computer. And we may touch on that down the road. We might do another video based on the questions. So what we're trying to do is answer your questions that you ask us, and want to show you what we've done and what you can do. And it's all about, let's make this work and keep it simple. So I'm going to go to some links. I'm going to also show overhead, because I want to show you this computer that we've got here is what we've been doing work with. And this is about an 8 to 10-year-old computer, and it's almost easier to install a capture card in an older computer than it is a new computer because of resource allocation. It's just, I want to get into some of that and talk about those specs. Now, not the vendor specs, manufacturer specs, but what we think it's going to take. And I'll say right now, you need an i7 or better. Anything less than that, don't mess with it. If you're on a laptop, you're looking at 4 cores. If you're on a desktop, you're looking at 10 cores. And if you're on a laptop and you're doing 4 cores, you can capture or you can stream, but I wouldn't do both. So if you're doing this technology through a laptop, keep it to one thing, keep it simple, and only do streaming. And I'll show you some of the stuff we've done. What I didn't understand when we started with this, and it's an easy thing to overlook, I didn't understand the bandwidth, because if you don't have the bandwidth to stream, but unless nobody's told you that and outlined that, it's like wow. So I want to take you on some links, show you where we started with capturing about 8 years ago, and it's all because of everything when it went digital. But when everything went HDMI, then everything kind of opened up, a whole new can of worms, but a whole new set of opportunities. Now I've got my favorites for different reasons, and the first one I want to show you, now this says this card is currently not available. It has been available, but this is by AVerMedia, and the way to find this is the AVerMedia CO27, especially if you're looking for drivers. 3 things we need to look at. 1, this is an internal card. Number 2, it takes a single lane slot. Number 3, it's PCI Express 2. And oh, by the way, all these capture devices we're going to look at, whether you want to do 1080 or whether you want to do 4K, they're all PCI Express 2.0. They're not PCI Express 3.0. Now, there are other devices that I'm not going to get into with this video because we're going to keep this simple. One device, one input, one output. Whatever else you have on the input and whatever else you have on the output, that's a whole nother animal. But there are ways that you can build on this. My goal and my concern is I don't want to see somebody buying something, wasting money, and wishing they'd have done something different. So I'm hoping an overview will kind of give you an idea where we've come from, and this is where we started. This has two inputs, and I probably have, I'll zoom in right there, you can see an HDMI input and an AV input. What that amounts to is an HDMI input for the capture. The AV input was for the analog. It looked like an HDMI plug, but it had a multi-pin cable on it that plugged in all the stuff to do analog. We never tried it. This is a proprietary card. It did one thing and only one thing. It captured. But it was a bit of a bear to work with because even though it captured, it did a good job of capturing. It captured an MP4. And I got to say, at one time, we had 4 of those, 4 different computers. Card was really cool. Kind of expensive comparatively now, but for what it did, you could capture with that, and the capture was a 1080 29.97 video. So that was something good enough to watch. If you're watching, I'll just say whatever content you're capturing. The one thing these required, though, for capturing, you had to have a splitter. I won't get any more into that, because that allowed you to do 3 things with a splitter. 1, to boost the signal. 2, to do the split so you could go into the card, but you could still see what was on the computer on a monitor. And number 3, to take care of something else that was a bit of a problem. And I'll just say HDMI 1.3, I think it was B. I'll leave it at that. Now that card worked in this computer. This computer being an AMD 8350, which is 8 cores, 8 threads, a Gigabyte 990 FX motherboard. I'd have to take a look at the specs to see which one. What I'm going to do when we get to the point is look at the card that's in here and show you what we've been using. I could capture and stream with this, but sometimes it would get bogged down because while I was doing the capture, which was a default, the stream sometime was a problem. But I'm going to come back to this. Right now I want to keep this on the path of 1, 2, 3. I want to try to keep it simple. But this machine is where we were at 8 years ago. It still works. It still does what it did. It can still do that. This card, even though it's a dinosaur, it can still capture, but that's all it does. It cannot stream. This was, without getting into the details of a lot of the technology, this was groundbreaking at the time. The next card we looked at, and I hope I pronounced this correctly, Hauppauge, the Hauppauge Colossus PCI Express, and it was an internal PVR, personal video recorder. What was really neat about it, again, you had access to analog and digital. All we ever did was the digital, but one unique thing about it, it had an SPDIF, a Sony Philips digital interface. So you had an AV in, an optical in, you had an AV out, and an optical out. And then you also had an infrared remote you could put on it. This card, again, required a single lane slot. But what was unique about the card, it was supposed to be able to capture 5.1 channel sound. Okay, I had about 40 hours on that card, and I never could capture a reliable capture because every time, every capture was inconsistent. Someplace it would pixelate. The file format was proprietary. You had to export. It was just, everything had to be done twice, and it really, really got cumbersome. It was a dog. It was a great idea, but it was a dog. But that's where the technology was at the time, and even though it was bleeding edge technology, it was just PITA. It was terrible. So then we moved on to the third device. Now this device, again by AVerMedia, ExtremeCap U3. U3 meaning it required a USB 3 port. Now, in defense of the device, I got to tell you, first of all, we never got that thing to work reliably. And I don't think it was the problem with the device. I think the problem was the chipset. And because of a history we've had with chipsets, going back to this machine, that's why I wanted to have this up here to tell you about it. PCI Express 2.0 was pretty easy. USB 2.0 was pretty easy. And I've got it in the device I'll show you. But this device required USB 3. And USB 3, which is still a problem for AMD. For those of you that are on Intel, you probably never experienced this. but there's something with the chipsets they were using that the chipsets were not designed for streams. They could handle data where you plugged in like a USB stick, you had that data, it stopped, you pulled the device out. Those worked, that was fine. But as soon as you hooked up something like this, when you started streaming, the chipset would disconnect and said, I got a problem, I can't do that. You'd have to reboot the computer to come back, you'd go through that and over again. So the definition of insanity. We had to get rid of that device. Again, it was not the device. The key is a chipset that can stream. And I think the problem that we're going to have right now, according to AMD, they think they can solve this on the current computers of the class that we're talking about building. They think they can do it with a firmware update, which implies something with the CPU. Well, based on our experience, this is all about the chipset, and the chipset you want to use is something based on the NEC Renesas chipset. You can look that up, and I'll put a link up to some Renesas chipset cards. There are some out there. So if you got a computer and you want to do that on USB 3, a device like that or any other device that requires USB 3, the first thing you need to have is a chipset that can handle the bandwidth. I think there's several things related, and I'm trying to decide how to share that. One is this issue with USB 3. Two is the issue with DPC latency. They're somewhat related, but they're a little different. And number three, we have another user, a subscriber, who has one of those fancy Oculus headsets. And when he hooks up the headset and there's another device he hooks up with it, it drops. And I think the issue has to do with the chipset. So I'm telling you about this because it's been a problem. It was a problem for us on AMD. We didn't experience it on Intel, but we didn't try it on Intel. So those of you that have an Intel chipset and it's working, great. But for those of us on AMD from 8 years back to right now, don't. So going forward, if you can do it on USB 2, which is 1080 for USB 2, and if you're trying to do 4K, if it's an internal device or if it's external, what I would be looking at is going past that and looking at an interface that's made for bandwidth, which might be Thunderbolt or USB-C. So I want to throw that out there as a side note. Let's get back to the history. I also did not care for the software, but again, this was supposed to be able to do 1080, 60, and we couldn't get anything reliable out of it. But I don't think it was the device. Historically, back then, what we knew then and what we know now, I think it was the chipset. So then the next device we went to, this device is available, this device works, this device is bulletproof, and I got to tell you, it's my #1 favorite. And we have experimented with this on desktops and laptops. And the other version of this that works on a desktop is the one that's the counterpart to this in this machine. But that, for 1080, bulletproof. What you have is hardware, you have software that you download, a driver's required. When you call up the software, you can check for updates, it automatically updates. It's incredible. Once you put in your streaming key for your CDN, which is your content delivery network, you're in business. The cable comes with it, USB, which also is your power and data. Then you'll have to have an HDMI to connect this, and I'll get into all that if we go to that direction on your streaming. But with our setup, that I may get into if we talk about that, what I want to focus on right now is the device, input, and output. This thing is bulletproof. And the nice thing about it, it's an external device. It'll work anywhere. And that's the Elgato Game Capture HD60, 1080p, and that's 1080-60. So from our standpoint and perspective, we could do 1080 59.94. On a side note, if you're streaming, depending on how you record, and we record 1080 59.94, I can get more into that level at another time. But I'll just say 1080 59.94 is what we use when we record and what we edit. But usually what we upload to YouTube is 1080 29.97. Why? Bandwidth. And I'm going to address that issue of bandwidth in just a minute, because that brings up an interesting question, whether you're going to stream live or whether you want to capture, record, and then put the video up. There's two ways you can go with that. And there's advantages to live streaming, but there's also disadvantages, because everybody expects when you're doing something for everything to happen. And this is a good example. I have the ability, because this is post where I have recorded this, we record this, we edit, We put some credits, the overlays on it, and it makes it look a little bit slicker. Some of the slickness I'm not after, and I can get more into that as well, because some of that, you know, this is about how to do things. This is more technical than it is about that. But if you're looking for a device to do 1080, that'll work. My preference, though, is the one that's in the computer. We used this extensively before we went to the internal. Now, there's two things to look at. With this external device that we're talking about, the Elgato Game Capture HD60, this requires on the processing power of the computer, whereas the internal card that's the counterpart to this uses its own processing power. It's got a processor built onto the card. So this you have to use for a laptop, and I've used this on the HP Envy-17T. We have a video on that. 4 cores. I have captured with it, but you don't want to, and you need to turn off the preview display with the software. Again, if we get into this, I'll show you that. All you want to do with this on a laptop like that would be to stream. Whereas this, I can capture and stream, but I'm only doing that. I'm not doing other things, even though I have other stuff installed. I will say we did have some times with this computer where we lost our stream. Come to find out, we happened to have an application installed for zooming, because I was doing a lot of experimentation looking at the different applications for zooming. Microsoft application is the easiest. It works. It doesn't cause other things to crash. Anyway, that one little application would cause the computer to lock up sometimes, and took me a while to figure it out, but when I did, believe me, that little application was toast. So that's the Elgato Game Capture, external. And if you notice on the end, there's an input. There's also, I'd like to show you what's going on with that, but that picture's lousy. So what I'll do is just take this out of the box, show you here. And this is the way I always transport it, because it's easier to keep track of everything. This little device, the HD60, we got 3 possible connections. I've got an audio input, I've got HDMI, and I've got the USB, which is for power. On this end, I have an HDMI out. So what I would do, let's take a look at what comes with it. I have the USB cable. So what I would do is plug the USB cable into this, and that gives me the connection to the computer. Okay, we've established connection with this to the computer. Then what I do is I do the input, and I plug the input into this so that then I can see what this sees through that input. The output would be like a pass-through connector if I wanted to plug in a monitor, or if I wanted to plug in an external device to record. Again, the nice thing about this, the software interface that comes with this, you can capture and stream with the software that comes with this. So you don't have to have a third-party application to do that with. 2 simple cables. And another thing I need to mention, wherever your source is for your video and for your audio, like what we're doing here, those two need to come in at the same place at the same time. If they come in at different places in the chain, you're going to have issues with delays, and that is a problem. So there's a lot of different ways of doing things. As we go forward, if the questions come up, I'll show you how we do it, because we've been doing this for quite a long time. Our experience started when we were on LCD projectors, and we had a live meeting, and we had to get a computer up on that live projector. And then one day we decided to start trying to do more and show more. So then we had to show more computers, and we had to deal with that. So after we dealt with that, then we went this next level, and okay, well, how do we stream? And we took our live meeting to a live audience, studio audience, to a stream that was on YouTube. And as we went through those 3 levels, we had an opportunity to grow our audience, which is now no longer a live audience, but you guys on YouTube, to do what we're now doing. But we had that history to get there. But this, I can live stream everything I do now, and I can switch all my inputs, because all that occurs before this device, so you can see everything. My problem is I'm one person. Right now I'm a one-man band. I used to have help at the live meeting. Right now it's just me. So it's easier for me to record it, and I cut out the bits and pieces where I go from camera to another camera, because I have to reach over, tap the computer that has the controller that changes that camera input. And I can also have 4 inputs on screen at one time, which we've done with some of the videos talking about the M.2 drives. And we have another quad card we're going to get back to real soon. But I wanted to kind of explain this, the device, to the input, to the output. And the output of this goes through the computer, through this cable, and out onto the internet. So, device, input, output. And that's my favorite, one of my favorite. Now the next device we went to, and this is an upgrade of the Elgato. I'll have a link up to this one. This is the Elgato Game Capture HD60S, and it'll do 1080p 60. Beautiful piece of equipment. Also includes an extra cable. I've shown you the model we used. Then Elgato came out with a Cam Link. I don't want to get a whole lot into the Cam Link, but I will say the original Elgato Cam Link was a stinker. Like this, it requires the processing power of a computer. So I was trying to evaluate and see how low of a computer that could go with. This device from Elgato will take the output from our video switch so that we can stream all of our content. The Elgato Cam Link would not take the output from our video switch. And there is a list now for the Elgato Cam Link 4 of cameras that it will work with. So I have no idea if it'll work with a video switch. I have no idea why it didn't work, but I will say, trying to use the Elgato Cam Link on a computer that we had rack mounted, another video, we crashed both of those computers because it couldn't do what that needed, and when they went BSOD, it was toast. Fortunately, I had a clone I was able to change, but that was a stinker of a device. So if you decide to go with something like an Elgato Cam Link, the Elgato Cam Link 4, double check it. Two things. This requires a USB 3 port. I don't like USB 3 on AMD. And number two, it's very finicky about the devices it's hooked up to. Hopefully the 4K version is better, but I didn't like it. And this is the Elgato Cam Link 4. Again, it says it'll do 1080 60 or it'll do 4K 30. And that's another thing I need to bring up. As Joe Winery always said, 4K, is it a feature, is it a benefit? If you don't need it, then there's no point in messing with it. I want to get through this hardware, then we're going to come back and address the issue of bandwidth as it relates to what kind of bandwidth is required to stream, whether it's 1080, whether it's 4K, how to test that in advance. Because when you go live, you're there and the whole world sees you. One time for first impressions. Now this is the device that's in this computer, and it's an impressive device. It works. Again, it's got its own processor so that it does not depend so heavily upon the CPU to do its work. But again, the laptop, to run this device, I can do this with a 4-core processor. So an HP Envy-17T was perfect. This is a 10-core, 10-thread machine. I prefer that because I could do the capture and the stream without any problems as long as I didn't do anything else. Capturing was great, streaming was great. It works. It's in this machine and it still functions. And what I'm going to do is spin this around, take the lid off, we'll take a look at it. And for those of you that are the neat freaks, don't look at that. I'm showing you this to let you see how this sets up. So I've got the lid off, let's spin that around, and this is still turned on so you get an idea of the full specs on this computer. This was a pretty big deal at the time when we built it. And if you notice, the video card in here is a GTX GeForce 980 Ti. And the capture card is sitting right there. Elgato Gaming. Right there. Now, as I look at the business end, I've got an input and I've got an output. The drawing on this shows that this requires a single lane slot. And remember, this is PCI Express 2.0. It's almost easier to put one of these capture card devices in an older computer than it is a new one because of PCI Express resource allocation. Even though it's PCI Express 2.0 on the newer computers, some of those slots, that resource has to be allocated. It's not always on. What we got into with the older machines, there was a device bus prioritization. And what you would get into is you'd had to put it in a slot and try it. If you had it in the wrong slot and it didn't work, then you had to try it in another slot. There was no way to set resources 10 years ago for PCI Express devices. 10 years ago, we were still just coming out of dealing with IRQs. So we've come a long way. But I wanted to show you in this machine how this works and where this sits. And the fact that we have an input and an output. Okay, so the question, how does that work? Well, that's what I like. That's what I like the simplicity of this device to show. If I'm going to capture video, then I am recording video. If I'm going to stream video, I'm going to broadcast it. So capturing is bringing in, broadcasting or streaming is going out. You have to have the device, you have to have something input and something on the output. And that's what I like about this device. I think it makes it easy for a demonstration to understand how all that works. So what we may do is another video just on this device to explain this, because you're talking about the device, input, output. That's one input. Even with all this elaborate setup that we've got, I still take the output from the video switch that controls all the inputs and goes into this and do my switching with hardware into this device. So there's lots of possibilities, but this is just one example. What I wanted to demonstrate when we do this with rack mount cases, as I've said before, a computer should be purpose built. There's a lot of things we can do, there's a lot of things we shouldn't do, but we can have a lot of stuff installed, we just don't use it all at once. So if I'm using a computer that I'm going to stream with, that's one thing I'm going to do. I may also have the software installed, which I do, where I could also control the video switch. But I also have the ability, because I'm using this device to stream within the software that comes with this, to do a capture. So I'm recording this, which for most people makes sense, because what if there's a hiccup on your stream? You need to be able to capture it so you can continue with your whatever you're doing. And if your live stream has a hiccup, you still got material on the hard drive and you can keep doing your presentation. Whereas if you've got something that is strictly for streaming, depending on the nature of the device, and we're talking consumer devices, well, when the stream stops, your broadcast stops and you're kind of SOL. So I like a safety net. I like something that does more than once, but I like something that works. This works. And that was my goal, to share this with you. And like I said, I don't mind doing this. I might even do a live stream to demonstrate and just do like a little 5-minute clip to show you how easy it is to set it up. But it's a great device. It works. It's been working. How long has it been available? Let's take a look at how long this Elgato gaming card's been available. What I'll do is just a quick search on the ASIN number, and that'll give me the date. This card's been available since September of 2015. So we've been able to capture, going on about 8 years now, we've been able to stream with this caliber and class of hardware now since 2015. So, wow, didn't realize. But there's other ways of doing this, but this is all about what capture card is best to put in one of these computers, as we looked at the 4 levels: entry level, secondary, high-end desktop, and workstation. We can put in, and all these are going to be PCI Express 2, we can put in a card that takes a single lane slot, which will be 1080, or we can put in a card that requires a 4-lane slot, still PCI Express 2, that'll do 4K. But the question I have to ask again, is it feature or benefit? Are you really going to stream 4K? We need to take a look at what's required to stream 1080 first. Now this is the computer we do the streaming on. What I'm going to do, and we're going to go to Google Speed Test. The first test we used to use was testmy.net. The one we recommend now is the Google Speed Test. And what we're going to do is we'll let this test run, and it'll show us what's going to happen. It's going to look at our bandwidth, and most of us think of internet bandwidth as download speed. Well, what's crucial here is not download speed, because you're going to stream, you've got to have upload speed. So right now I have a 253 megabit download speed, but what's crucial is my upload speed. I've got 12 megabit. Okay, right there is what I can stream at, 12 megabit. Your internet connection is fast. Your internet connection should be available to handle multiple devices streaming HD videos, video conferencing, gaming at the same time. Test again. And I'm in Houston, so I'm connected to a server in Dallas, which is where my server's at. Okay, that's a key number. Now, for those that say they want to stream, what can you do with 12 megabit upload? At 12 megabit upload, you're going to need between about 8 and 10 to do an upload of 1080, 59.94. You've got to allow for some variance in the bandwidth. There's this back and forth flow that occurs. So at 12 megabit, I'm good, and I can stream at 1080, 60, or 1080, 59.94. 1080, 59.94 is the broadcast standard of the cameras that we use. So I'll leave it at that. We can get more into that later. Now what's important is, if you say, okay, I want to stream 4K, multiply that times 4. So I have to ask the question again. 4K, is it a benefit or is it a feature? If it's a feature, do you need it? If it's a benefit, if it's something you have to have, then you're going to have bandwidth 4 times that. The only way you're going to have that is if you have a fiber connection, some type of a gigabit connection, because it's all about the upload speed. You've got to be able to send that stream out, and that's for that one computer doing that. Don't let other people on other devices, phone or whatever, be on that same stream, because it'll mess up your stream. Now, that's for streaming for 1080. If you're on something like, say, Zoom is 720, it's not 1080. Zoom, the way they've optimized their codec, probably like a 3.5 megabit connection. And when someone has trouble streaming on Zoom, that tells you what kind of bandwidth they've got, because they've probably got a 3.5 megabit upload connection and they're not getting 3.5 megabit. So with 12 megabit, I can stream 1080. When we were at Chapelwood, they had fiber, and that was one of our goals, is we were going to stream 4K. We didn't get that far. We had some remodeling to do. Then things didn't work out. We weren't able to have a live meeting, and so they've got fiber, but we didn't get the chance to stream 4K, because as any of this stuff goes, I know what I know from experience, but some of this stuff I don't know because I haven't done it, and I'm trying to share with you based on these specs of the equipment as we go through this historical perspective, what's available, what you can do, and what you can't do. So if you think you want to put a 4K capture card in there, is it something you really need? Is it something you're going to use? I hear where you're coming from, but I have to ask the question, is it a feature or is it a benefit? Do you have a 4K camera? Does your 4K camera give you clean HDMI out? And does that clean HDMI out give you 4K? All that matters. Because if you don't get 4K out of that camera, then you don't need a 4K capture card. And oh, by the way, if you don't have the bandwidth, it ain't going to work. So this was one key ingredient. When we first started, we were able to do capture. Then we were able to stream. And when we first started streaming, on probably the first maybe 3 videos, I didn't understand the issue with bandwidth. But I figured it out. And where we were at, because we were in a meeting facility, we were at Fairhaven United Methodist Church, they didn't have the bandwidth. So our group, as a group, collectively stepped up, and we got Comcast Business in there. And once we got that into the facility, we were able to increase the bandwidth. We were then able to live stream. And once we realized 1080 didn't work, for a while we streamed at 720. But as soon as we got internet in, which took us about 6 months, we got it back up to 1080. So I'm telling you what happens. It'll pixelate and the signal will cut out, because you got to have the bandwidth, you got to have the variance. So if you want to stream 1080, 12 megabit upload. If you want to do 4K, 4 times that. You do the math, you got to have a gigabit connection, which is, if you can get it on copper, fine. But if you got it on fiber, all the better. So I hope that kind of gives you some insight. I got some more links I want to show you. One more thing I got to say before I do these links. Anybody that wants to stream, if you're going to put a capture and streaming card in your computer, I would first take an inventory of that computer if it's an older computer, because like I said, this is in a 10-year-old computer. Now when Nathaniel brought his machine over, everything he had according to the specs in his computer, being a 10-year-old computer, it was a lesser processor in terms of speed, but it was still 8 cores, 8 threads. The point being, he can install either a capture card if he chose to, or a capture device, meaning external, to that computer, and he could capture and stream. My concern was his video card. It was only 2 gigs. It would do the job, but I would have it do just streaming. But that's not where he's at, what he wants to do. He wants to go beyond that. And the reason I'm referencing this, install Bella Arc Advisor, inventory your computer, especially if it's an older computer, and see what you've got. If you've got the basics. On a laptop, you need at least 4 cores, 16 gigs of RAM. On a desktop, I would say 8 cores, 16 gigs of RAM. I believe this machine probably has 32 gigs. But all the other stuff, when you start capturing, that's a lot of drive space you're going to fill. What you'll have to do after every time you do a stream, because you're capturing and streaming, if you leave that default setting, take those files and move them to another drive. Now, with 1080, most people are good with a 2 gig drive. It'll last them for a year. But when you go to 4K and you're doing 4 times as much data, you can do the math. Instead of that drive of 2 gig lasting a year, that 2 gig drive is going to last 1/4 that amount of time. So you're going to be offloading those videos a lot more often. I'm just saying. There's variances and variables that you have to allow for. Now, so that we get into this and cover this the way you guys have been asking, I've shown you 2 devices that'll do 1080. One's internal, one's external. And the external will work with the desktop, it'll work with a laptop. For those that want to do the 4K, I hear where you're coming from. We've got 2 4K cards we're going to look at. I'm going to put them in this list, and we'll do separate videos as unboxings on those 2 devices. What I won't be able to do is stream with them because I don't have the bandwidth. 12 gigabit is all I have got. All I can stream with the bandwidth I've got is 1080. But I'll show you what I can based on what the cards can do, and we'll go from there. This first card is by AVerMedia, and this is the AVerMedia Live Gamer 4K. This will do 4K 60, so from our perspective, that'll do 4K 59.94. That's a pretty big file to put up. If you look at the slot, it's PCI Express 2.0. That takes 4 lanes, 4 PCI Express lanes. It has 2 connections on it, and there it shows PCI Express Generation 2 by 4. They also have a Thunderbolt 3 device, and I can't say for certain. We may take a look at a Thunderbolt streaming device later because Thunderbolt is better situated for bandwidth than USB 3 was to do the throughput. But from our perspective on the computers of the 4 different levels we were talking about building, we're going to look at this capture card. Then the next capture card we're going to look at will be the Elgato 4K 60 Pro. And again, it takes a 4-lane slot. It's PCI Express 2.0. And they claim again they can do 4K 60, which from our perspective will be 4K 59.94. Because we use a broadcast video switch, we're using a Blackmagic, and this is a Blackmagic ATEM2 ME Production Studio 4K. The default setting for the Blackmagic video switch is 59.94. The default setting for the cameras is 59.94. So that broadcast standard of 59.94 is what we do, that's what we embrace. It just keeps things simple. What we put out on a stream, though, is according to our bandwidth. What we put out as a video to record could be 1080, could be 4K. My preference, based on my experience, because I've had real good experience and I've had real good luck with Elgato, is the Elgato card. So what I want to do, and I haven't looked at either one of the cards yet, I want to experience them as a new user would, even though I know how they work. We're going to take a look at the AVerMedia card first, because our original start with capturing was AVerMedia, and then we'll go back with another video and look at the Elgato. And this is long overdue for us to do this, but I felt it was important and relevant from a historical perspective to get into this, kind of see where this plays out as a beginner's guide. And I also need to interject one real big distinction with the 4K capture cards. There's a setting in the BIOS that you need to change for that 4K capture device if you're going to capture 4K, which is the 4G decoding. Turn that on, otherwise you will have dropped frames with your 4K capture. So that one little tidbit of information, I believe I've got some documentation on that, and I think it goes to Elgato where they mention that. Some of that's kind of hard to find. It's kind of like DPC latency. Some of that too is kind of hard to find. But as we go through this, we want to keep it simple, make it work. And if somebody were to ask me which one I prefer without looking at either one, based on my experience, would I go with AVerMedia or would I go with Elgato? My preference would be Elgato. You can look at the price of the two, and you can look at that accordingly. But I think we need to drill down more than just on the surface of what the description has to say about the two. We need to look at the specs and see what kind of file we get out of it. And Elgato now is owned by Corsair, which is kind of wild. One last thing I want to mention are the cables for HDMI. I'm not a big fan of HDMI, but everything that we do has to be HDMI. Because of the video switch, we have to be able to convert everything to HDMI. I don't care if it's DisplayPort, mini DisplayPort, whatever. We have to go to HDMI. We go through converters. For example, this computer that I'm looking at, or I should say that we are looking at, this computer is running. For me to be able to look at the screen, I have to go through a converter, which is a decimator. So I come out of the video card with this HDMI cable I'm showing you, and the reason for it, these cables by Sanus do not put a lot of weight on the connection. They're very lightweight. And because of the limitation of the length, this is good for 18 gigabit, which is 1080. It says it'll do 4K. We've only used it for 1080, but we've used a lot of HDMI cables. I've had the best luck with these. And the problem we've had with HDMI connectors, as the cables appear to be getting loose, then what we do is we just replace the cable, and we're back in business again. They have two different lengths, an 8-foot and a 4-foot, and I want to point those cables out, but they're worth every penny because they're lightweight. We've looked at some of the ultra thin or ultra slim cables like Monoprice. Those are Redmere. Do not get involved with Redmere cables. What will happen? They will appear to work sometime and they won't work some other times. You can unplug them, plug them back in, and they'll work. And then the next time you plug them in, they won't work. Believe me, I did a whole lot of that, and that's a real hassle. Nothing wrong with the cables, it's just the technology is not quite where it needs to be. So stay away from Redmere cables. They've got smarts in one end that allows them to boost the signal, and it's not worth the trouble. Stick with something simple, but stick with those ultra thin cables. When we first started using HDMI, we went with the standard cables that were big as a pencil, and they weighted the connectors down, and when they got long, it was a problem. I mention this now because there is another cable that we've been asked to look at by a manufacturer where we can go really, really long, which is bizarre, and it's a fiber cable. So that's something we're going to be looking at using a fiber cable where, say, we have a capture device that we want to stream with, where we hook up a camera so we can see how far we can get that camera away from that device, beyond 8 feet. So that's another cable we're going to be looking at. But I wanted to share this with you, and I'll have it up in the links. Now, there's a lot of different aspects to capturing and streaming, but our goal was to talk about capturing, look at the history, talk about streaming. We looked at the bandwidth that's required. The bandwidth's a big deal. And as we look at the devices, there's 3 things you need to think about: the device itself, the input, and the output. Any one of these devices with one input, it's about what you do. As I said, when we started, because we had multiple computers we were putting up on a projector, we had to figure out some way to get those multiple computers and move that faster. So you have 2 computers hooked up to a projector. You had to go into the projector to change the input. It would blink and come back. Well, then we went to HDMI switches, and still you had that blink where it would go away. If you try to use one of those HDMI switches with something like this, with a capture streaming device, what will happen is, because it does not see the stream disconnects and stops. That's why we had to go to something that kept that stream not just blinking out, but would change that signal and keep that signal constant. That was one of the reasons we went to a video switch. So have a problem, solve it. How do you solve it? Another piece of hardware. One thing calls for something else. But what we want to do is to show how this works, to keep it simple with the history. The links I'll have up. And the next video coming up, there's a lot of stuff going on. I'm hoping it's going to be about one of these devices. Now that I've talked to you about bandwidth, so you kind of see feature or benefit. You know, what I need and what I want could be 2 different things. And as it relates to the computers, this particular computer is PCI Express 2. So back then we would have referred to this as having 3 full-length slots and then 2 of those little slots. And we have this in one of those small slots. We could put a 4K capture card in here. I don't see that ever happening. This computer does what it does, and when we retire it, we'll move on to something else. Because it's getting time after 8 or 10 years, and I say this because a lot of you guys are coming out of the woodwork wanting to build another 10-year computer. The entry-level computer is about a 2-year computer. The secondary level computer is about a 3-year computer. The best deal is on the Gigabyte TRX40 Designaire, that TRX40 chipset with 2 16-lane slots, 2 8-lane slots, depending on the allocation of resources, and there will be another 1 or 2 1-lane slots where you could put another capture card in. Could be a single-lane capture card, or could be a 4K capture card that requires 4 lanes. So I mentioned that, and as you go to a workstation, you've got 7 16-lane slots, gobs of space to do things. So as a purpose-built computer for content creation, for all the things we're doing, there's lots of options. And I will say, for those that want to know, how do you do this without a computer, desktop or laptop? And I'll say, then you move into something more of a professional type, and there's 4 leading manufacturers that do this. My favorite, number 1 is LiveView. Number 2 is Teradek. Teradek has the most extensive ecosystem, but I like the infrastructure and the way LiveView does what they do. I'll have some links up for that. There's 2 others that I don't know how they're going to position going forward, so I'll just put a link up to those 2. But that way you have a device where you can go anywhere. You're not tethered. You don't have to have a connection hardwired like this. With a professional solution, you do it like a news crew, and you've got a device that fits in a backpack that has maybe 4 modems that bonds or aggregates 4 different internet connections, wireless internet connections. So you can then stream 1080 or you can stream 4K, and it's doable, but it comes at a price. We might explore some of that based on the question. So this was about clarity. If we didn't answer your question, ask, and we'll do our best. Tell us what you want to do, and we'll give you some idea of how to do that. How somebody else does it, you know, I don't know. I would say ask them. I've told you and shown you how we've done and what we're doing, some of the things that we do. And I can show you what the technology is, because that's what we're all about, the technology. There's some really cool stuff going on right now. And that's one of the things I've done with Behind the Scenes, which is my other channel, to get into some of that stuff. But as it overlaps now with Build or Buy, it's becoming more relevant for what we're doing here. If you guys are more into the streaming and you want to see more of that stuff, ask the questions, let me know, because our goal is about answering questions. And by the way, my name is Gil Boyd. This is Build or Buy. I want to thank you guys for joining us. I love my subscribers. On to the next video. Stay tuned.